All right. So this is unfortunately the boring stuff, but it's easy. All right. So first off, let's skip that. Okay. So what we're going to do first is we're going to look at diagrams. We're going to look at diagrams. We're going to look at the markings that are in the diagrams. We're going to determine if things are true or false based on what's in the diagram. So we have to look for the congruent marks. We have to look for right angle marks. We have to look for those things that our eyes recognize. Okay. Write this down. Your test is on Thursday. Okay. So first we're going to do is we're going to look at some postulates. Okay. These postulates are kind of what make things work in geometry. So for example, if you have any 2 points, I don't care where they're at, any 2 points, they can be connected by a line. Okay. So think of it as a conditional statement. If you have 2 points, then you have a line. Okay. Doesn't matter if they're connected, what you visually see or not. If you have 2 points, then you have a line. Well, the converse of that is also true, because if you have a line, then you have at least 2 points. So if you have a line, then you have at least 2 points. So any 2 points make a line, and a line has 2 points. And then, of course, you have the intersection of 2 lines. The intersection of 2 lines will always be exactly 1 point. Will not be more than 1 point, because unless they're curved. But if you have 2 straight lines, they will intersect at exactly 1 point. All right. The 3-point postulate and the plane point postulate are kind of like the postulates 1 and 2. They reverse each other. If you have any 3 non-collinear points, then you're going to have a plane. So you have points D, E, and F. Well, since they're not all on the same line, then that means there's a plane. Keep in mind, this should have been one of those fancy letters, because this is just your label. Okay, because we can call this plane R, or we can call this plane DEF. Okay, remember when you're naming a plane, you can use 3 non-collinear points or the fancy letter in the corner. So if I have 3 non-collinear points, then there's a plane. So if you have 3 non-collinear points, then you have a plane. Well, if you have a plane, then you have at least 3 points. Okay, so that would be a biconditional. Through any 3 non-collinear points, through any 3 non-collinear points, 3 non-collinear points exist. Let's see. If and only if there exists exactly 1 plane. Through any 3 non-collinear points, if and only if there exists. I'd have to think about how to word that one. A plane exists if and only if there are 3 non-collinear points. That would be a biconditional. And then the last one here says, if 2 points are in a plane, well, if I have 2 points, I can draw a line. So if I can draw a line, then that means the line is also in the plane. So if you think about your wall, if you were to hammer in 2 nails where the nails are representing points, could you connect the 2 nails? If you could connect the 2 points for the string is going to represent a line. Is that line or that string on the wall? So then, therefore, if you have 2 points on a plane, then that line is also in the plane. Okay? And some of these are kind of hard to see. You just have to visualize it. And then the next one is, if you have 2 planes and they intersect at a line. If you look at the ceiling and the wall, anywhere, at home, here, at the restaurant, wherever. When they intersect at the corner. Well, if I drew a line through the corner, that's because a line is the point of intersection for two planes. So two lines intersect at a point, two planes intersect at a line. So these next exercises, we're just going to state what the pictures are representing. So if I have at least some points here, and I connect them all, then that would be the first postulate, 2-point postulate, or the 2-point postulate 2.1, which states that if given 2 points, then there's exactly one line. Well, if there's 3 points or 4 points or 5 points, it doesn't matter if they're all on the same line because you have at least 2. And that's all I needed to make a line. All right. The next one, if I have a plane with some points, then I have a plane with some points and a line. Well, which postulate would that be? That would be the last, that 2.6, which states if 2 points lie on a plane or in a plane, then the line containing them lies in the plane. So I could have made any line. I could have connected this one as well. I could have said this one. Or I could have did this one. So as long as you have 2 points, then you can make a line on the plane as well. Okay. All right. Next. Now, I'm going to give you a description, and you're going to draw what I'm describing. Okay. Kind of the opposite of charades, where you draw a picture and I have to guess what you're drawing. So you're going to draw ray RS, but it has to be bisecting line KL at point R. So first of all, if it's bisecting, that means it's cutting it in half. So I need to think, okay, this ray is cutting this line in half. So that means point R must be the midpoint. So then that would look like this. Here's line KL. R is the midpoint because it's been bisected. So that means that KR is congruent to RL. And then ray RS is a segment bisector. All right, the next one says that I have a line. It's in a plane. It's intersecting another line at this particular point. So we have 2 lines that are intersecting. But the point on the second line is not on the plane. So how do you draw a line that's not on a plane? It has to be going through it. So then you would have this. You have line AB, which is on the plane. You have a line that is intersecting that line, but one of the points can't be in the plane also. So that means it has to go through the plane. If it can't be on the plane, then it has to go through the plane. All right, the next one says that I have a line that's intersecting a segment at a point. That point has to be the midpoint because 2 things are equal to each other, right? So then if TW is congruent to WV, then that means W is on TV. So the segment PQ has to go through that. So you have to think about, what are they giving me? What do I have to work with? And then create your sketch from that information. So you have to pay attention to congruent signs, bisecting words, and things like that. All right, so here we're going to look at this picture. You have 2 planes that are intersecting, and we're going to decide if they intersect at line EF. So if you think about plane A goes to like right here, if you just look at the top part, and then plane B, if you just look at the top part, they intersect at EF. So true, 2 planes intersect at one line. So the definition, they intersect at one line, and they do intersect at EF. Points C and D are collinear. Even though they're not connected, what do we know? Well, I know that any 2 points can make a line. So true. Any 2 points can make a line, and if any 2 points can make a line, then therefore they're collinear. The next one is talking about a ray and a line being perpendicular. So when I see the word perpendicular, I'm going to automatically think about 90 degrees because perpendicular lines make a 90-degree angle. So then I'm going to look in the picture and see if there's a 90-degree angle and see if it's placed where these two intersect. So if I look at HJ, so over here is HJ. So HJ is this ray, and then ID would be that line segment there. They do intersect where the right angle is. So therefore, true, because there is a right angle box in the picture. It's labeled for me. I don't have to assume it based on a postulate. I know it's true because they're telling me it's true in the picture. In number 9, they're talking about line GD is a bisector of line EF. Well, first of all, if they're talking about a bisector, then I need to look for congruent tick marks. Okay, so it's a bisector of EF. So I need to look at EF. So here is E and here is F. Well, if I connect E and F, not like that. If I connect E and F, and then I notice there are these matching tick marks, so that means D is the midpoint. Well, if D is the midpoint, and then G is here, so GD is a bisector of EF at point D. It shows that your ED is congruent to DF. Some of these are obvious, some of these are not as obvious. So the next thing says IH is congruent to HG. So here is IH, here is HG. There are no marks in this picture showing me that those are equal. Do they look equal to my eyes? Yeah, they do, but they are not. I don't care how much they look equal, unless they tell you they're equal, they are not. So here for number 10, I would say this is false. It's not marked or told. So just because it looks a certain way doesn't mean it's true. You can only use facts, definitions, and properties. You cannot use eyeball assumptions. So here it says that angle HJD and angle HDJ are complementary. So I need to remember that complementary means two angles that add up to 90 degrees. So I'm going to look up here and find these two angles and see if I can determine if they are complementary. So angle HJD, so H to J to D. So they're talking about this angle right here. And then HDJ, so H to D to J, so this would be this angle over here. But what I do notice is that I have a triangle HJD. So if I were to look at this as a triangle instead of, so if I just kind of color it in where my eyes are more focused in that area of the picture, and I see that it happens to be a right triangle. Well, what I know about a right triangle is, first of all, I know there's 180 degrees in every single triangle, no matter what. This is 90 degrees, so if I subtract 90, that gives me 90 degrees left over for these two angles. So that means that this angle J, so I'm going to call this angle 1, and I'm going to call this angle 2. So that means angle 1 plus angle 2 has to add up to 90. So therefore, yes, it is true that angle H is a right angle and triangle HJD is a right triangle. So the remaining angles have to add up to 90. So they are complementary. And that is it for the notes.